Okay, let's start. Hello everyone. I'm Saniya Irfan and welcome to this new series on data structures. In this video, we will understand what data structures are, why we need them, and how they form the foundation of efficient programming. Let's begin. First thing is as we can see on PPT, what's data? Data are the raw facts that needs to be processed to form an information. Look, data is just a random data. Like it could be about anything, about leaf, about walls, about home structures. Like it's just an random anything. And when we process it and we convert into information, it means we extract information from raw data. Okay, and second very basic thing is computer. Like what's computer? Okay, computer is an electronic device that stores and processes data in the form of binary digits. Look, computer is just a device which could store and process data, and in which form? In binary digits. Okay, and then we move. What are data structure? Listen properly. A data structure is simply a way to store and organize data so it can be used efficiently. Different structures allow different operations like searching, inserting, or deleting data much faster than others. Every program we write, even the simplest one, like you can say about the linear regression, and any like even let take as a hello world, okay, uses some sort of and some kind of data structures. Next, how computer stores data. As we see in our previous slide also, that it stores it in binary digits, which is only 0 and 1. You could like it convert any data in 0 and 1 and stores it in the our electronic device, which is called as computer. Third is, why do we need data structures? We need data structure is to improve performance. With the right structure, we can reduce the time it takes to process data and also save memory. When our application grow, data structure help us solve complex in a clean and scalable way. Data structures and categories. Here I have mentioned four categories, which is linear, non-linear, static, and dynamic. Linear structure store data in sequence like arrays and linked list. Non-linear structures data stored in hierarchical or connected form like trees or graph. Static structures have fixed size, while dynamic ones can grow and shrink based on need. Okay, then it's basic operations. No, mat no matter which data structure we use, there are some common operations. Okay, it's insertion, deletion, searching, traversing, and updating. Different data structure handle these operations at different speed, and that's why choosing the right one is important. Type of data structure, very important too. Okay, we usually divide structure in two broad categories. Which first is a primitive type such as int, float, character, and boolean, and then non-primitive type, which is include linear and non-linear structure. Primitive types are the building blocks, while non-primitive types let us build a powerful and complex systems. Let's move forward. It is linear data structure. Linear data structure are the simplest form of data organization. They include arrays, linked lists, stacks, and queues. These structures arrange data in sequence, and their simplicity makes them perfect for many day-to-day problems in programming. Non-linear data structures allows data to be stored in multiple level or relationships. Example include trees, graphs, heaps, and tries. We see them everywhere. File systems are trees, social networks are graph, and heap are used in operating system for scheduling. Choosing our data structure. The choice of data structure depends on what our program need. If we want fast searching, we might use a hash table. If we want hierarchical relationship, we use trees. If memory is limited, we choose a structure that uses space efficiently. Choosing the right structure makes our code clean, fast, and reliable. Real world applications. Data structures are everywhere in real world applications. Database use tree structures to store and retrieve records efficiently. Browsers use stack to manage your back and forward navigations. Maps and navigation app use graphs to find the shortest path. Even operating system use queues for scheduling tasks. Importance for interviews. Listen, data structures are the heart of technical interviews. Companies test your understanding of how data is stored, accessed, and managed. A strong knowledge of DSA not only help in cracking interviews but also improve your problem solving and coding ability. So, in the next video, we will explore each data structure one by one. We will start with arrays, then moves to linked list, stacks, queues, trees, and graph. Each video will include concepts, examples, and small coding demos. And thank you for watching. If you found this useful, do like this video and follow for more CS fundamentals and DSA contents. You can also connect with me on LinkedIn and read my articles on Medium. See you in next video.